Welcome back, folks. In today's video, we will talk about the adding and subtracting of the fractions, algebraic fractions, and then we will also try and solve for the value of x when you have algebraic expressions given to you. So these are the two things we will talk about in our today's class. So I'll start with the adding and subtracting of algebraic terms. So first term, which I'm gonna take as a question, that is 1 over 2 plus 1 over 3. If I am adding these two numbers, what do I need to do? I will multiply this with 2, this with 2, and this with 3, and this with 3. So I can add them. So this is 3 over 6 plus 2 over 6, and then the base is same, that is 6, and this will be 5 over 6. So please make sure you're not confusing yourself with the multiplication, because this, if it was in multiplication, I would have multiplied straight across. So this was 1 over 6. But in algebraic addition, what do I need to do? I need to have the common denominator. Accidentally, in this case, the denominator came out to be the 6 in both the cases, here and here also. But first of all, in this case, I have to have the common denominator. Then I write the denominator as it is and add the top on top of that. So for example, 1 over 2 plus 1 over 4. So to make the denominator common, I'll multiply this term with 2, this with whatever operation I'm applying on the bottom, I have to apply on the top too. So this will become 2 over 4 plus 1 over 4. Now the bottoms are same. I can write the bottom as same. So 2 plus 1 is 3. So this will be the answer. Whereas if it was in multiplication, I would have written it as 1 over 8. So do you see the difference? What is the difference between the addition and subtraction? Oh, addition, subtraction, and the multiplication. So multiplication is totally different from addition or subtraction. And now let's look into an algebraic term. So the question is ax minus 1 and plus ax plus 1. Now how we're going to simplify this one? I need to multiply this one with x plus 1. So I have to apply the same operation on top. This one with x minus 1, x minus 1. So this will become x plus 1 upon a plus a x minus 1. This is x minus 1, x plus 1. Now the base is same. Here I will write x plus 1. X plus 1, x minus 1. The base is same, and the top will be ax plus 1 plus ax minus 1. I can open up the top now after this. So ax plus a plus ax minus a upon x plus 1, x minus 1. And then I can cancel these two terms. Ax plus ax upon x plus 1, x minus 1, and a will be, well, these two are like terms, 2ax upon x plus 1, x minus 1, x minus 1 here. Okay, so that's how you're gonna add or subtract them. Now the next question is, if the question looks like this: 3x upon 2x square minus 2x minus 24 minus x minus 1 upon x square minus 8x plus 16. What you're going to do is, first of all, you have to convert it into the simpler fractions. So you will get the number as, oops, so the numbers you're going to get is 3x upon, if you do the math, I will encourage you guys to do the fractions by yourself. So 2 times 24 is negative 48, and find the factors of negative 48. I'll leave that part for you guys. The factors will come out to be 2, x minus 4, and x plus 3. These are the factors you're gonna get for the given question. And then uh, here on the other side, x minus 1, I can convert this into the fraction form also. The fraction numbers will be x minus 4 whole square, or x minus 4, x minus 4. These are the numbers you're going to get for the fractions on the other side. Now the next thing will be I have to make the denominator same. There is x minus 4 here, x minus 4 here, and I need to have one more x minus 4 on this side. So I'll multiply x minus 4 on this side. Here I'll multiply x plus 3 on this side. So x plus 3 on top here also, x minus 4 on top here too. Now I'll multiply this with 2, another 2 here. Now the base is exactly the same. So I'll take the common base, x minus 4, x plus 3, x minus 4. The base is same, and I'll connect the upper terms. 3x, x minus 4 minus 2x minus 1, x plus 3. And then 3x square minus 12x minus 2x minus minus plus 2. Here, please make sure if you're multiplying this with one of the terms, you don't distribute it to the other, because these two terms are in multiplication. This is where please make sure you're not making a mistake. So this 2 goes away now, okay? Because all three are in multiplication. You just multiply these two terms and that 2 goes away, and you're left with x plus 3 on this side. And but what you're gonna do here is, I shouldn't put a bracket because I've distributed the 2 also in there. Well, actually this can be a little tricky. I will place a negative here. See, this is little complicated thing. I'll place a bracket here. I'll keep a bracket here, and this will be 2x minus 2, then 2x minus 2, and this is like this. I've only distributed 2 inside, not negative 2. Now what I'm gonna do, if I distribute this negative also, okay, the bottom will remain as it is. First of all, x minus 4, x plus 3, and x minus 4. Now if I distribute this negative to both the terms, so how it's gonna look like, see here, this is a little complicated. So this becomes plus, this will become negative 2x plus 2. That's how it's gonna look like, x plus 3. They will still be in the bracket because both the terms are in multiplication with x plus 3. So this is kind of a little tricky to simplify. So now on the bottom side, it is this is 2x minus 4 whole square, these two combined together, x plus 3. So x plus 3, I cannot cancel it. Please make sure you don't start canceling it. Some students start doing this. That's wrong. Whatever is you canceling out has to be common to both numerator and denominator, means in multiplication. If it was like this, then you could have easily canceled this and this, but right now you cannot cancel. So for example, 5 plus 3 over 5, you cannot cancel this. You cannot write answer is 3. If it was 5, 2 plus 3, this 5 belongs to this 5 belongs to this. Now you can cancel it. All right, so hopefully you were able to understand that concept, 3x square minus 12. And then once I'm going to open the bracket, I will get a long term from here actually. So I will write it as plus negative 2x. I'm solving these two now. Negative 2x, x plus 3, and plus 2, x plus 3. And now on the bottom it is 2x plus x minus 4 square, x minus x plus 3, and then 3x square minus 12, and plus uh, this will become minus 2x square minus this will be minus and minus 6x plus 2x and plus 6. Oh boy, this is a lengthy question. I didn't think this is gonna go that lengthy. Anyhow, x plus 3, and then I can combine the like terms here. 3x square minus 12 plus minus 2x square minus 4x plus 6. And now I can drop the brackets. So the numbers will be well, on the bottom it will be like this, x minus 4 square x plus 3, and then 3x square minus 12 minus 2x square minus 4x plus 6, and then I will collect the like terms from the top. The bottom's gonna remain as it is, x plus 3 here, and this will give me x square minus 4x, and this is minus 6 over x, not x, here it is 2, x minus 4 square x plus 3. Now can I reduce the top to some smaller terms? I can reduce the top to some of the smaller terms. Here I think I am making a slight mistake. See, I'll keep on leaving this x here. So this was x. So luckily it didn't create much of a damage to my question. So this was 12x. So here it will change. So this will be uh, 12 and 4 minus 16x plus 6. That's how it's going to look like. And can I simplify it more than this? If I can, I'll see the factors of 6, 3 and 2. No, I cannot simplify furthermore. So this will be my final answer. So that's how you're going to solve questions when you are combining, adding or subtracting the two fractional numbers. Hopefully you were able to understand this. Again, if you're not been able to follow up, if you have any questions, so you can always come and follow up for these questions to me in the library starting third week on Saturday 12 to 4. All right, so now I'm gonna try and solve some of the equations. So for example, the question gonna look like 2x plus 1 minus 1 upon x equal to minus 2 upon x square plus x. Now when you have a algebraic term and you have to solve it, first thing you have to is you have to find the non-permissible values. First thing you should do, even if you're not finding it for the simplify questions, that's okay. But when you have to solve it, solve and simplify are two different things. Simplify means convert it into the easier term. Solve means you have to find the value of x. So find the non-permissible value, NPV. So x plus 1 is equal to 0. X cannot be equal to negative 1. Here x square plus x equal to 0. I'm taking this one after this. So I will put x common, x plus 1 equal to 0. So I'll write x cannot be equal to 0. This cannot be x equal to 0 or x plus 1 equal to 0. So from here I'll write x cannot be equal to negative 1, x cannot be equal to 0. From this one I'll put x cannot be equal to 0 directly. So two are repeating. So x cannot be equal to 0 and negative 1. These are the non-permissible value which I figured out. Now I'll try and simplify this question. So I'll rewrite the terms one more time. 2 upon x plus 1 minus 1 upon x equal to minus 2 upon x square plus x. Now what can I do about this question? I can multiply this one with x. So I'll multiply this one with x and x on top. The other term I will multiply with x plus 1 on top here. Now it's gonna look like 2x. This will be x square plus 1 minus, see carefully, this minus will belong to both the terms. So I will put a bracket in front here so that I'm not confusing myself. So x square plus 1 equal to x square plus x. Actually x square plus x I shall write, not 1, because this will become x, this will become x minus 2. Now here comes a situation. If the denominator is same on both sides of equality, so here I can write the denominator as x square plus x, 2x minus 1 equal to minus 2 upon x square plus x. If the denominator is same on both sides of the equality, I will cancel out the denominator, and 2x minus 1 equal to minus 2. And this will become, this is gonna, you will bring it on the other side. You can move one on the other side, this on the other side. These two, subtract them. This is going to become x, and this is minus 2 plus 1, x equal to minus 1. So x, we got the value x equal to minus 1. But minus 1 cannot be your answer. So x, which, what did we say? Non-permissible value. X cannot be minus 1 or 0. X cannot be negative 1. So your final answer will be x has no solution. No solution. No solution for this kind of a question. So hopefully you were able to understand how you're gonna solve the questions. One more question I'm gonna try and do for you guys. So if the question looks like x over 12 minus 1 over 8 equal to x plus 2 over 6. Now bottom has all the numeral values, no x value, so you don't need to find any non-permissible value. What you can say, 12 cannot be equal to 0. We all know that 12 cannot be equal to 0. So only if there is x thing in the bottom, then you find the non-permissible value. So you will multiply this with 2, this with 3. So 3 here, 3 here. So this is 3x over 24 minus 3 upon 24 equal to x plus 2. And then you can multiply, this is 6, multiply by 4, multiply by 4. So 3x minus 3 over 24 equal to 4x plus 2 over 24. The base is same. I can cancel them out. 3x minus 3 equal to 4x plus 8. And then this I will rearrange the terms. And this is going to become 4x. Well, actually 4x minus 3x and minus 3 minus 8. So 4x minus 3x is x. This will be negative 11. X value will be equal to negative 11 I got, but I am not sure where I'm making a mistake. Actually, I don't know why I multiplied by 3 here. 2. See, this is where I was making a mistake. So this will be 2x, not 3x, 2x. So 2x here, 2x here. So this will become 2x. So 2, so this will become 2, dividing both sides by 2. 11 over 2 will be your answer, x equal to negative 11 over 2. So that's how you're going to simplify the fraction question. So I've given you the idea how you're going to approach these fractional questions. So I'll encourage you guys to try and do lots and lots of questions from chapter number 6 up to 6.8. So try and do as many questions you can, and if you have any questions you can always come and see me in tutorials. And yeah, that's it from my side for chapter 6. I'll see you in another chapter. Till then, goodbye.